Welcome back to our fourth lecture of macroeconomics on equilibrium output and the multiplier. Before, we did see Keynes's explanation of both consumption C and investment I by showing that the main determinant of consumption is income or Y, and that the main determinant of investment is the interest rate or R. Here we consider Keynes's view or theory of equilibrium output or income. Specifically, we show how equilibrium output or income is determined. The determination of equilibrium output or income. Simply, Keynes views or says that the level of aggregate output or income will be exactly as much as the level of planned aggregate expenditure, denoted as AE, or the sum of consumption, investment, government expenditure, and exports and imports for the economy. That is, generally, the level of aggregate output or income will be as much as households spend on consumer goods, businesses spend on capital goods, government spends on both types of goods, and finally, as much as foreigners and citizens spend on such goods. So, equilibrium will only occur when there is no tendency for change. In the macroeconomic goods market, equilibrium occurs when planned aggregate expenditure is equal to aggregate output, where planned aggregate expenditure, or AE, which is the total amount the economy plans to spend in a given period, that equal to consumption plus planned investment. Or algebraically, we can write AE is identical to or equal C plus I. So equilibrium can also be written as a condition in the form Y, or income equals C plus I. But what if planned aggregate expenditure, or AE, falls short of or is less than income or Y? In this case, businesses will add or increase their inventories of goods in order to restore equilibrium. Also, if planned aggregate expenditure exceeds income or Y, in this case, businesses will withdraw or decrease their inventories in order to restore equilibrium again. Generally speaking, there are two approaches or two methods that can be used to determine the equilibrium level of output or income. The first approach is known as the aggregate expenditure income or output approach to equilibrium. The second is the so-called the saving investment approach or method to equilibrium. So let's look at the first approach, the aggregate expenditure income approach. This approach says that equilibrium output is achieved or occurs when aggregate output or income denoted as Y equal aggregate expenditure denoted as AE, or the sum of C plus I, that is the sum of consumption and investment. The second approach, the saving investment approach, says that equilibrium occurs or is achieved when the level of saving equal the level of investment. So, according to the first approach, the equilibrium equation or condition is Y equal C plus I, and according to the second approach, the equilibrium or the equation for equilibrium is simply S equal. The table we see here gives an example of applying or using the first approach to determine the equilibrium level of output. Here we have a consumption function given by column 1 and 2. So looking at column 1, we have several or different levels of income, starting at 100, then going to 200, 400, 500, 600, down to 1000. The associated levels of consumption are 175 at a level of income 100, consumption level of 250 at a level of 200 of income, and so on down to a level of consumption of 850 at an income level of 1000. Also, we have in column 3, as we can see from the table, the value of investment. And as you can see, the value of investment given in column 3 of value 25, and we are assuming that the value of investment in the economy is constant or considered as an exogenous variable, which is 25, a constant value at each level of the different level of income, starting from 100 and ending at 1000. In column 4, we see the calculated value of aggregate expenditure, or AE, at the sum of CI. In column 5, we can calculate the amount or the value of unplanned inventory. And finally, in column 6, we see whether aggregate expenditure is equal to income or not. Here we will see how we can calculate the value of planned aggregate expenditure, or AE, given by the sum of consumption and investment, or simply C plus I. So for example, at an income level of 100, we add the value of consumption, which is 175 or 175, and the value of investment, which is 25. Both 175 and 25 add up to 200. So we got the first number in column 4 this way. Also, at a level of income of 200, we have a value for consumption, which is 250, to be added to 25. Both sum up to 275. Also, at a level of income of 400, we have a level of consumption of 400 to be added to the value of investment, which is 25. So 400 plus 25 is going to give us 425. We can continue calculating the remaining values for planned aggregate expenditure at the remaining levels of income in the same way or using the same method. Here we can calculate the value of unplanned inventory change by subtracting the value of aggregate expenditure, or C plus I, from the corresponding level of income. So for example, we can calculate the unplanned inventory change at level of income of 100 by subtracting 200 from 100. We get a change, a negative change of 100, or simply minus 100. At an income level of 200, we subtract the value of AE, or aggregate expenditure, which is 275, from the value of corresponding income, which is 200. In this case, we get also a negative value for the change in inventory, which is 75, or simply minus 75. We can continue doing this in column 5, as you can see, for the remaining values of income. And you should notice that at an income level of 500, we see that the value of unplanned inventory change is 0, and this simply means that the value of planned aggregate expenditure is identical to the value of aggregate, and this is why we get a difference of 0. And only at that income level, which is 500, we see that equilibrium occurs or is achieved. In this case, we can see that y equal C plus I, 475 plus 25, sum up to 500. So at an income level, and more accurately, only at an income level of 500, we see that aggregate expenditure is equal to aggregate output, or income. The table we have here gives an example of using the second approach for determining equilibrium output or income, and that is using the saving investment approach. As you can see from the table, we have two pieces of information. The first is given by column 1 and 2, representing or giving us the consumption function, and column 1 and 4 gives us the associated or the corresponding saving function. So for example, we can calculate each value in column 4 by subtracting the value C, or consumption, from the corresponding value of income. So for example, at an income level of 100, we can obtain the value of planned saving, which is minus 75, by subtracting the value of consumption, which is 175, from the value of income, which is 100. We can do the same thing at an income level of 400 by subtracting the value of consumption, which is 400, from the value of income, which is also 400. So this results in a value of 0 for saving. While at an income level of 400, we can obtain the value of saving, which is 25. This is given by subtracting the value of consumption, which is 475, from the corresponding value of income, which is 500. So the difference between 500 and 475 gives us a value of 25 for saving. And by focusing on column 1 and column 3 and 4, we can see that only at an income level of 500 that the value of planned investment, which is 25, is equal to the value corresponding for planned saving. And as you know, this is the equilibrium condition required to be fulfilled or satisfied in order for equilibrium to happen or occur. So at an income level of 500, we see that S equal I, simply 25 equal 25. According to this, the equilibrium level of income is 500. Finally, we have to note that or see that the equilibrium level of income, which is 500, is the same as the equilibrium level of income or output obtained previously using the aggregate expenditure output or income approach. So both approaches should give us the same value for the equilibrium level of output or income, which is in this case 500. Here we can see from the table that the equilibrium level of output or income is 500, as can be seen in column 1, and the corresponding equilibrium level of consumption is 475. The equilibrium level of saving is 25. And at this level of income only, we see that the value of saving is equal to the value of investment, and also, as we did see before, the value of consumption plus investment is equal to the value of income, which is 500. Basically, we should note that, we should realize that using the two approaches to determine the equilibrium level of output or income should give us the same value, one value for the equilibrium level of output. The graph given here represents the results we obtained in our previous numerical example. The example showing the determination, or how to determine the equilibrium level of output or income using schedules or tables. In the upper part of our graph, we see three things. First, investment is given by a straight line parallel to the horizontal axis. The consumption function is drawn in blue as an upward sloping line representing the consumption function C equal 100 plus 0.75y, and also we see above the consumption function given in blue the aggregate expenditure function given as C plus I. And as you can see, the difference or the vertical distance between the CI line and the consumption line is constant along the different levels, or at the different levels of income, which is equal to 25. In the lower graph, we see that the aggregate expenditure line is drawn as an upward sloping line representing the sum of consumption C and investment I. Also, we introduced in the same graph, we have drawn the 45-degree line, which represents y. So we can determine the equilibrium level of output, which is determined at a level of income of 500, at which we see that the AE line drawn in red intersects with the 45-degree line. And here we see that the planned aggregate expenditure function crosses the 45-degree line at a single point where y equal 500. Also, the point at which the two lines crosses is sometimes called the Keynesian Cross. Here we have a solved problem. Find the equilibrium level of output or income, but this time using algebra. So you are given the equilibrium condition as y equals c plus I. You are given also c equal 100 plus 0.75 y, which is the consumption function. And finally, you are given investment, I equal 25, representing planned investment. As you can see, we want to find the equilibrium level of output. So all you need to do is to substitute in the equilibrium condition given in the first line, y equals c plus I. We basically substitute for c using the consumption function or the consumption equation, c equal 100 plus 0.75 y, and replacing the value of I by 25. We will find that y equal 100 plus 0.75 times y plus 25. Rearranging terms, we move 0.75y to the left-hand side of the equation, so we obtain y minus 0.75y equal the remaining terms, which are 100 plus 25. Continue, you will find that subtracting 0.75y from y gives us 0.25y plus 125, which is the sum of 125. Finally, we can solve this equation for y to find the value of y. So we have y equal 125 in the numerator divided by 0.25 in the denominator, giving us 500. 500 is the value of the equilibrium output in this case. Note here that we can obtain the corresponding equilibrium level of consumption if we substitute back in the consumption function c equal 100 plus 0.75y. We substitute for the equilibrium level of y, replace y by 500, we can get the corresponding value for C, or consumption in this case. Note also we can calculate corresponding value of equilibrium saving. This can be obtained or calculated by subtracting the value of equilibrium consumption from the value of y, which is 500. The saving investment approach to equilibrium. We know that y is identical to the sum of C and S. This means that income is the sum of consumption and saving. This is an identity, as we know, and the equilibrium condition is y equals C plus I. but this is not an identity because it does not hold when out of equilibrium, when we are not in the equilibrium position. By substituting c plus s for y in the equilibrium condition, we have c plus s equals c plus I. So canceling out c from both sides, we end up with s equal I, or saving equal investment. Equilibrium occurs in this case only when planned investment equals saving. The graph we have here shows the equilibrium level of output or income as determined using the second approach or the saving investment approach. As you can see from the graph, basically we have the saving function drawn as an upward sloping line starting at a value of minus 100, and also we have investment represented by the red line or straight line parallel to the horizontal axis. As you can see, equilibrium is determined at a level of income of 500, at which we see that the saving function crosses or intersects the investment function I. Aggregate output is equal to planned aggregate expenditure only when saving equals planned investment, or only when S equal I. Saving and planned investment are equal at Y equal 500. Adjustment to equilibrium. If firms react to unplanned inventory reductions or increases in the opposite case by increasing output, an economy with planned spending greater or less than output will adjust to equilibrium with Y higher or lower than before. The two previous figures shows that at any level of output above or below Y equal 500, output either will fall or rise till it reaches equilibrium at Y equal 500. Now we consider the concept of the multiplier. The multiplier is the ratio of the change in the equilibrium level of output to a change in some exogenous variable. Our exogenous variable so far is investment, or I. An exogenous variable is a variable that is assumed not to depend on the state of the economy, that is, it does not change when the economy changes. The size of the multiplier depends on the slope of the planned aggregate expenditure line, the slope of the AE line. And note that the steeper the slope of this line, as the slope of the aggregate expenditure line or the AE line increases, the greater the change in output for a given change in investment, which is our exogenous variable in this case. The graph given here shows the multiplier as seen in the planned aggregate expenditure diagram. At point A, the economy is in equilibrium at Y equal 500. When I increases, let's say by 25, in this case, planned aggregate expenditure is initially greater than aggregate output. As output rises in response or as a result of additional consumption is generated, pushing equilibrium output by a multiple of the initial increase in I, or investment. The new equilibrium is found at point B where y equals 600. Equilibrium output has increased, in this case, by 100, which is the difference between 600 and 500. So we calculate the change or the increase in y by subtracting 500 from 600. Or, as you can see, that difference represents 4 times the amount of the increase in planned investment. Here we show the calculation or calculating the value of the multiplier. And let's recall that the marginal propensity to save is calculated by dividing the change in S or saving by the change in income or Y. Because delta S must be equal to delta I for equilibrium to be restored, we can substitute delta I for delta S and solve. So we have MPS equal delta I divided by delta Y. Also, we have delta Y equal delta I times 1 divided by 1 minus MPS. Therefore, the value of the multiplier is given by 1 divided by MPS, or simply the reciprocal of the marginal propensity to save, or the value of the multiplier is given by the reciprocal of the difference between 1 and the value of the marginal propensity to save, or simply 1 divided by 1 minus MPS. The paradox of thrift. Here we have 2 saving lines or 2 saving functions. The lower is S0 and the higher one is S1. And we have the investment line I. We note that an increase in planned saving from S0 to S1 causes equilibrium output to decrease from 500 to 300. The corresponding decreased consumption leads to a reduction of income. Increased efforts to save have caused a drop in income, but no overall change in saving. This case is known as the paradox of thrift. Note that the size of the multiplier in practice is lower or is reduced when: number 1, tax payments depend on income. 2, we consider the central bank behavior regarding the interest rate. 3, when we add the price level to our model or analysis. And finally, when imports are introduced in our model. In reality, the size of a multiplier is about 2.